Hello everyone, I'm Yukang. This is our State Space Explorer project for Innova Technologies. We built an algorithm to help the Australian Navy train on their new mass defense system. The team is Chimu, Yetai, Junyang, Xinghai, Christine, and me. Let me pass to Chimu to explain the problem.
Okay, I'm gonna introduce this. So the Navy just got these mass systems to protect ships from the missiles using the electromagnetic countermeasures. They need to train operators, but you can just shoot real missiles at ships. So we simulate the problem is the state space has about 2 times 10 to the 20 parameters combinations. If we simulated each one for a second, it would take 9 trillion years. Obviously impossible. Our challenge was to predict the whole space using minimal space samples. We have 3 user groups. Navy train offers need to accurate simulating fast defense analysis, optimize strategies, and engineer turn system parameters. The core question is how we predict a median point by owning simply a fraction. Yetai will show you how to work it.
He's a typical senior. Next PowerPoint. Oh yeah. Here's a typical senior. A trainee officer set up a mission. When at 15 knots from 217 degrees. Ship to in 20 knots heading south. Missile income at 500 meters per second from bear 045. Then our system take over. We set midpoints across the 3D space using KDT and IDW. This run in under 2 minutes. The system mass effectiveness at 87.3%. Fingers out at the best timing for countermeasures and suggest the parameter to tweaks. You can see in the diagram we sample specific points and use them to entire surface. But we only need 300K first. Junyang will explain our user stories.
We organize develop around the user stories. User story one was about efficient quarreling. As a Navy officer, I was to quarrel the state space within my budget, so I got accurate prediction without simulating everything. We built a uniform random spread algorithm to cover 30% of space with 300K squirrels. No sleeping bars. That was 8 story points. User story two focus on speed. As an engineer, I was prediction in under 2 minutes, so I literally quickly we use a KD tree spread index to which gives our O log n third time combined with vectorized number py operations and batch processing 10 case points at a time. We hit the target 30 stories points complete. Both stories work actually as designed. Xinhai has the remaining stories.
Go to the next slide. Three more stories. Users, story, three handles, periodic boundaries. As an analyst, I want accurate predictions at the edges so corner cases work right. We developed a tiling technique that replicates training data at I minus 100, I and I plus 100 keeps predictions smooth across boundaries. 8 points down. User story 4 is multi-dimensional support. Users want 1D, 2D, and 3D state spaces depending on scenario complexity. We built that flexibility in 5 points down. User story 5 handles stochastic environments. Training officers need the system to work with noisy measurements because real-world data is never perfect. We tested this uh, row so roughly 8 points down, all 5 stories, 39 total story points completed. Christian will explain the technical architecture.
Our architecture. Our architecture has 5 layers. State space input goes to uniform sampling, which feeds into KD tree with our tiling technique, then IDW prediction, and finally output. The core algorithm works like this. For any query point, we use KD tree to find the 5 nearest neighbors in log time. If the point is an exact match, we return that value. Otherwise, we calculate weights as 1 over distance squared, normalize them, and compute the weighted average. That's inverse distance weighting. Our tech stack is Python 3.9 with NumPy for numeric operations, SciPy for KD tree and interpolation, and scikit-learn as a fallback for Gaussian process regression when needed. The system is fast because KD tree lookup is logarithmic and we batch all the calculations. Back to you, Kang, for progress.
We ran 4 sprints over 12 weeks. Sprint 1 was basic Gaussian process implementation. Sprint 2 focuses on RBF and optimization. Sprint 3, we developed competition-specific strategies. Sprint 4, we finished the KD tree solution. Our velocity went from 12 story points in Sprint 1 to 45 in Sprint 4. That shows we got better as we learned. Key achievements: all 5 user story done. Execution time down from 10 minutes to 1.8 minutes. That's 82% faster. Accuracy improved 35% with KD-tree. We handled the 3D competition with a medium point successfully. Competition scores were 8.2 out of 10 on cylindrical, 9.1 on stochastic, and 9.5 on the 3D medium scenario. Our team of 6 made 142 commits, wrote over 3,500 lines of code, and had 10% attendance, 100% attendance on weekly scrums. Kimu will talk about what's next.
Okay. Short term, next 3 months, we are building a GUI with interactive 3D visualizations so Navi authors can actually use this easily. We're adding GPU accelerations to get prediction time under 30 seconds. And we are exploring hybrid approaches with neural networks for better interpolations. Long term, 6 to 12 months, we want direct API integrations with Navimax simulators, multi-objectives optimizations for parameter search, and could develop on AWS or Azure for multi-user access. We know we are missing user assertions and a database for historical simulations. Those are priorities. Yet I will make conclusion.
Bottom line, we built a production-ready statement space explorer that solved a real problem. We took something that would like 10 to the 12 years and made it run in 2 minutes. That's the difference between impossible and particular. We hit 95% everything on benchmarks and use the proper throughout technological. We nailed the uniform sampling to eliminate space, combined the KD tree with IDW for faster productions, and handed bound race with Teleum process-wise. We had a strong communication, so weekly stand-ups, so the version control with Git branching and code reviews, and initiative developments across 4 sprints with continuous benchmarking, main license, early optimization matters at this circle, and domain knowledge about Navy options was a circle. That's it.